All right, let's get started as soon as this room's up. How was, what's the last part? How was trip planner front end reps? Good. That's the last of trip planner. So one of the goals of trip planner, in addition to learning kind of the basics of the web API and many of the things you can do with it, another goal is to get writing a trip planner out of your system so that we don't have quite so many trip planner capstones. This, at least according to David, is one of the reasons that's a project. So if you never want to think about trip planner again, that's mission accomplished. And in fact, this next workshop is super fun, I think. Most people like it. We're going to be making a real-time collaborative whiteboard. And then we'll set it up and you can all play on each other's whiteboards, and it's just really fun. And the way we're going to do this is using events, specifically event emitters, and Socket.io. So let's talk about event emitters first. You have actually seen these. Okay. So we've actually seen these in Node code somewhere or another. Every time you call server.listen, it actually returns an event emitter. So I think sometimes you'll see server.listen.onReady or something. And it's another way of dealing with asynchronous data flow. It's kind of like a promise that just keeps emitting things. That's one nice way to think about it. So we can create an event emitter, obviously new event emitter. We have to import it from the events module in Node, or pull it in from the events from Node's event module in the front end as well, which we can do. And then we can say somewhere in the program we can say okay, we'll get a reference to this maybe by importing it or by having it returned from the function, and then we can attach a listener by saying on new tweet, run this function. So every time the new tweet event is fired, that function will get called. And then elsewhere we can emit new tweet and send data through this pipe. That's how I think of event emitters. They're pipes. They're actually they're sort of many pipes, right? Because you can emit any kind of event and listen for any kind of event. There are many other similar patterns to this. You might see observables or RX observables mentioned somewhere, which are very much like event emitters that only ever emit one kind of event. They are just individual event streams. And they also have a bajillion methods on them to sort of cut up and interact with that event stream. Okay, great. So we listen here. This runs when this emits. So the thing that we emit, so when we call emit, we're calling it with a event type and then a payload is what that's called. This is an instance of the observable observer pattern. Observables are also an example of this. And Node introduced these because Node has a whole bunch of things that emit events, right? So every HTTP server emits events. It will emit a connect event whenever someone connects. It'll emit a closed event whenever it's shut down. And so it's a nice way to attach different behaviors to moments in an object's lifecycle. Practical use here is that we might want to send information from one part of an app to another, and those parts could be rather far apart. This gives us a way to coordinate that flow of data. We put, in this case, current track somewhere where both this view and this one can access it, and then we can emit from one and receive in the other. Another use of, so we'll see them used for, for file uploads, if you end up handling those from Node. Also, any time that you run another process or you do sort of a long-running thing in Node, you will get that the function that kicks that off will return an event emitter, which you can then listen for events on. There are a few other examples. DB on connection is a useful one. Actually, when we were using PG, all of those query functions we were calling actually returned event emitters, and we could have said, like, do this query dot on row, process each row individually. And the reason we're reintroducing you to event emitters is that socket.io, which is this library that gives us sort of real-time data streams into the browser, uses event emitters as the model for how you receive data sent by the server on the client. So let's talk about the underlying protocol that we're going to be using to send data through socket.io. So here's what we know about HTTP. Quick review. Clients make requests to the server receives the request and sends back a response. It's a one-to-one relationship, right? Every request gets one response, and that's it. The request may have a body if it's like a post request, and the response often includes a body if it's like a GET request. So this works well for sort of navigational events on pages. It works well for most web experiences. But you can probably imagine some ways in which it doesn't work, like chat rooms or the New York Times wanting to have a live stream of the World Cup. This is actually kind of a terrible example because the overhead of using this particular library would probably be too much for a very popular stream. But anyway, so the flow we want, rather than having a request-response cycle, is that we want the user to go to a web page, and we want that page to have sort of a live running stream of commentary. And on the back end, or like somewhere else, we have a commentator who's watching the game and like tweeting this live as it's happening. And whenever they do that, it should like show up immediately, or as close to immediately as possible for all the users watching the stream. So before we go on, what are some thoughts? How could you implement this? Yeah.
I regret this.
No regrets.
Here we are.
No regrets.
You could implement like a loop in your response.
Yeah. So you could just keep requesting, hey, is there anything else? Hey, is there anything else? Hey, is there anything else? And yeah, and actually the server doesn't have to respond immediately, right? You could say, hey, is there anything else? And the server could be like, well, no, not yet. So I'm just going to hold on to this. And the moment there is something else, I'm going to create a response and send it back. And maybe you structure into that something where you're like, hey, is there anything else? Here's the last thing I got from you. And the server waits until there's something more, and then it sends that back. And that is HTTP long polling. So we have our, wait, what is going on here? Oh yeah, so we have the server talking to the database, which this is kind of confusing. I would just expect it to be the server in the browser. When there's an update, the database will send back okay, here's the data, and then the server will send that to the client, and then the client makes another request and says, okay, here's the last thing you sent me, server, and the server is just going to hang on responding to that until there's something new, and then finally it'll respond. So the world will kind of be in this state of the client waiting for a response for possibly quite a long time. And that's fine. That poses some overhead on the server, but it is an expected and reasonable thing to do in HTTP. Yeah.
So in that example, if you were to sort of based on the FIFA World Cup example onto this, with the person who's doing the live tweeting or the updating or the stream or whatever that is, be updating the database here.
I honestly would, like, if I were designing those, I would cut out the database entirely and say, like, or say the database is, like, stored in memory somewhere. Like, it's not going to be big, right? It's going to be a relatively small amount of data, but it's going to need to be, like, very fast, and you want the server to get events when it's updated. So I would probably just say, like, hey, you've got another client over here that is the tweeter, the commentator, and that person is talking to the server, or their client is talking to the server. And when they send a new tweet, the server goes and updates, it like goes and sends back that tweet to everyone who's waiting for it. So there's no way to just, outside of the request response cycle, there's no way to just have the server say, yo, I think you are going to need this data. Or I think you will want this because you subscribed. The only way to, within HTTP, to sort of have this push behavior is to do long polling, which is kind of okay. Also, this is true of HTTP 1. HTTP 2 does have a way for the server to basically create a preemptive response to say, like, here's what you asked for, and here's a bunch of other things that you're probably going to need, which is useful if, for example, you want to serve all of the resources associated with the page. It's still not precisely live updating, though. HTTP 2 is the next version of the HTTP protocol. It's not super dissimilar in its semantics from the current version. That is, it has headers, it has like version line, it has like bodies, it has verbs, but all of that is wrapped up in a different encoding scheme. So instead of being text-based, it's this kind of it's like some efficient packing format to pack in all the header information. It's compressed by default. It is encrypted. It is only encrypted. I think it cannot be unencrypted. And it has a few other control, like sort of low-level network things, like being able to push additional data or additional resources. Okay, so let's talk about TCP for a second. This is the protocol that was built on top of IP in order to standardize the way that computers communicate with each other in when a reliable channel is needed. So TCP gives us, over the unreliable channel of the internet, a reliable duplex connection that persists over time. Reliable meaning that everything gets there in order, or you know that it failed, and duplex meaning that either end can send or receive. And persistent meaning that the connection sticks around until one side terminates it or until it times out, which is a provision in there because we think that one machine might have died. Somehow it fell off the network, it fell down a well, anything. At some point you want to release those resources on the other end. So TCP is a transport protocol, meaning that it sits on top of IP, which is the internet layer protocol, I think. But these layers have specific names. But it sits on top of another protocol and provides reliable transport. So it introduces some things that you're familiar with, like ports and connections, and some things that you're not familiar with because it hides them, like retries and flow control. The general ability to send data at only the rate that the receiver can actually receive it. So HTTP sits on top of TCP. It's an application layer protocol. It usually operates over TCP, but it can technically operate over others. It never does. I've never seen HTTP over something else. Except for HTTPS, which operates over an encrypted protocol that itself sits on top of TCP. If this is sounding like layers and layers, like building up onto each other, like a stack that's about to crumble, that is true. That is how everything runs. Yeah. It operates over port 443. So TCP introduces this idea of port numbers, which are just numbers that you put into a TCP packet saying like, hey, I'm connecting to the server. I want specifically to talk to the service that's running on port 80 in the case of a standard HTTP connection, or 443 in the case of an encrypted HTTP connection, which most are these days. And did that answer your question? Yeah, the first, is it 3,000 ports? Yeah, I thought it was less than 3,000, but maybe it is about 3,000. It's definitely the first, some like on the order of 1,000. I thought it was the first like 1,024 ports are, you cannot bind to them unless you are root, basically, or unless you have a special capability in the operating system, because they are kind of reserved for specific named services. And then ports above that are sort of like whatever. Yeah, I mean they're special only because they've been sort of decreed as like privileged ports for well-known services. The ports above them are not like any worse or any, they're not like treated differently, except that you don't need special permission to bind them generally. So TCP gave us a reliable connection. HTTP gives us the idea of a session, in which we create a single TCP socket and send requests and responses over it. So that looks like this. The client opens a TCP connection to the server with this like three-way handshake. You saw that joke someone posted, right? Like a TCP packet walks into a bar and asks the bartender for a beer. The bartender's like, "You want a beer?" The packet's like, "Yes, a beer." So that's the three-way handshake. It's the client says, "I want to connect." The server says, "Okay, I hear you. Let's connect." And the client says, "Okay, connection established." And then finally, there's a connection that's established. There is like SYN-ACK, SYN-ACK are the names of those packets. And then after that, a connection is established. The connection is not like a physical thing. It's an ephemeral thing. It exists as an idea within the TCP stacks of the client and the server. And then over that persistent stream, we can send HTTP requests. So we send a request, get a response. Typically, the connection stays open for us to send more requests and get more responses. Eventually, you close the tab, or you navigate away, or in some cases, the browser just has too many sockets open, and so it starts closing them down, and one side terminates the connection. Or the server gets bored, like you haven't said anything for a while, and it terminates the connection. So everything in HTTP 1 or 1.1 follows this request-response cycle. Client sends a request, server sends a response, and there's no more data that's pushed. This is obviously limiting, particularly in the World Cup case. And so we implemented, probably about 10 years ago, an extension to the HTTP protocol called WebSockets. And this extension lets a normal HTTP connection become something so much more. So the client, so HTTP is kind of a smart protocol in that it contained the ability to upgrade to another protocol to be defined later as part of a request. So a client can send a request that looks normal, except it has this upgrade header saying, hey, I want to I want to basically stop speaking stop speaking HTTP with you, and instead start speaking WebSocket. And it needs like all these headers, which like sort of specify the encryption and some sub protocols in the WebSocket protocol, and like various other things, like the version of the protocol we're using. If all of that looks in order and the server supports it, the server will be like, okay, I see you. We'll switch protocols. It's like when your parents start talking in Canada, they like somehow knew that that was the time to do it so that you couldn't hear. Maybe this is a me sort of experience. But the server says like, okay, I'll switch protocols. We've now upgraded our connection, and we're now speaking WebSocket. Thereafter, that connection, that TCP connection, belongs to the WebSocket protocol, which is a simple framing protocol that basically gives you, from client-side JavaScript, pretty direct access to just sending a stream of data to the server and getting a stream of data back. Sort of gives you back access to that underlying TCP connection with like a little bit of, there's like a little bit of layer in there, but not too much. So this is nice because you can implement like everything on top of it, right? Like after we have a duplex connection, it's very easy to just sit there and wait for the server to say, oh, I got a new tweet, and update the views accordingly. And I have good news. You don't have to implement all of this madness. There is a library called Socket.io, which implements it for you. It's actually two libraries, one designed to run on the server and one designed to run on the client. And they both extensively use event emitters to represent the flow of data between the client and server. Basically, you can emit an event on the server, and all the clients who are connected will hear it. So this is a good use case for, or this is a good technology to use for chat apps, collaborative applications, real-time stuff, games, and whiteboards, which we're going to implement this afternoon. So the drawbacks of using a WebSocket are that the server has to hold on to the connection until you close it, or until the server just runs out of file handles, which is a surprisingly easy thing for Node to do to a machine. Connections they're expensive, not because they require a ton of memory, but because they consume a file descriptor within the kernel, and there's only so many of those. There's like 65,000 or something, which means that a given machine can only hold about 65,000 open sockets, and actually much less because you need other things open in order for the machine to run. So if you have a bunch of sockets open and they are dormant for a long time, they're wasting server resources. Also, as your application scales, if you are sort of expecting everyone to be connecting to the same front end via sockets, that expectation will come back to bite you in the moment when you decide you need multiple servers, which is fairly early on in the scaling lifetime of any application. You might need to have many servers to handle all of the traffic, and then you would need some way of coordinating communication between those servers to get real-time updates. So there are real costs. There are also many applications for which this is fine, like, I don't know, remember when Minecraft servers, actually, probably don't use WebSockets, but they could use WebSockets. And that scaling issue is not so much an issue because each Minecraft server is its own thing. Other notes, documentation is actually fine at this point. The slide is a little old, but it leaves a little to be desired. The Socket.io library will automatically fall back to long polling if it somehow cannot establish a WebSocket connection, usually because the browser doesn't support it. And it has various capabilities for organizing your connectivity, basically. So you can cluster clients into different rooms and just send broadcasts to the room, or you can broadcast to all available sockets without having to sort of manage looping through all connections yourself. Yeah, so there's no real disadvantage to using WebSockets if they're available. They are, versus long polling at least. They're faster. They will more efficiently, they'll get you data from the server with lower latency because you don't, in the time between when you get an update and when you initiate a new request asking for the next update, there isn't that lag, right? Like with long polling, you have to create a new request. With a socket, you just are always listening for data. It both of them carry this penalty that you are consuming a connection on the server. In the case of long polling, the server is having to hold this connection open until there's data to send down it. In the case of WebSocket, same thing. The server is holding the connection open. Long polling is not, yeah, long polling is not better, I'm pretty sure, from the standpoint of connections consumed on this client either. Because if you have an outstanding request, I don't think you can send another response on that connection. It's basically just waiting. Yeah.
Just want to make sure, I think I missed somewhere slide. What's the kind of ordinance something? Or are they?
So a port is a concept within TCP, which identifies which service you are trying to connect to on a given machine. So it's a way of addressing an individual service within a machine. And a socket is so in this context, a WebSocket is a particular connection that has been established between a browser and the server that you can send data down.
So websites is like the format of.
Yeah, it's a protocol. It's a protocol that sort of piggybacks off of HTTP and then takes over the TCP connection, giving you more direct access to like a data stream rather than a request response.
Okay, and when you say websites, it's like sockets open, sockets or whatever.
Sorry, say that again?
Like when you're using WebSockets and sorry, I just missed like what is the socket part of it? WebSockets is the protocol. What is the socket?
The socket part of it is that it is like a TCP socket, where a TCP socket it's the lower level part of this, right? Like when I connect to a port, and when I connect to a TCP port and start sending data down it, the thing that is called in the operating system is a socket. Like create a socket and connect it, and like now I can send data down it.
Okay.
A WebSocket is not like quite. It's not directly a TCP socket. Like you don't get totally direct access to it.
Okay.
And in particular, you can't just open a connection to a random machine at a random port. But it gives you a similar interface. That is, you can send data and receive data, and you're just getting a stream of data that you know is reliably going to get there.
Okay. Oh, awesome.
Yeah.
Thanks.
Yeah.
Can you just revisit the beginning of this lecture when you were talking about event emitters?
Yeah.
Maybe just refresh our memories on what
On what
are.
this is going to look like.
Yeah, and
Totally.
how they relate to WebSockets.
Yeah, I'm actually going to change this. Oh my god, it's an image. Okay, I can't change it. Some of our slides, man. So, yeah, so here is a use of event emitters. And it's a particularly good one because I think this is actually from Twitter.js, right? Maybe we pulled it out. But this might happen on the server where when we get a new tweet, like as part of the route that adds a new tweet, at some point we emit tweets to a socket that we will have gotten when a client connects. And then this elsewhere would be on the front end. We can be listening on that same socket for new tweets and then adding them to the page. Yeah, and vice versa. Yeah, exactly. It's usually it's that it lets the client listen to the server more than the other way. Because the server's kind of always listening to the client. You can just make a request here. Yeah. Yeah, you would still have an express route that the client connects to. It's just you wouldn't call res.send until there's something to send. This works rather differently. You don't even you initialize socket.io with your Express server, but you don't really give it a route. It does kind of have a mapping to a URL somewhere, but that's pretty much hidden from you. And that's fine because you really just care about like, hey, did I get a socket connection established? And so you wait for that event from the socket library that says someone connected. That event sends you some data, which is like the actual socket that you can use to talk with them. And you can then call emit, or maybe more likely broadcast, which will send out an event to one, or in the case of broadcast, to all sockets that are currently connected, to all clients that are connected.
So the new event emit here is like the new socket.
Yeah, so this is the thing you would not have to call in order to get a socket. Instead, you would call like io.listen or something like that.
So an event emitter isn't a socket, but it works the same way.
A socket, the socket IO interface is event emitters. So it will give you event emitters. You won't have to like construct them explicitly. And also the whiteboard interface is implemented with event emitters as well. Mostly because we were on an event emitter kit. Right. If this feels a little bit confusing, I think this is actually harder to explain than just to dive into. So let's dive in. I think you'll find this fun. I hope you'll find this fun. And yeah, we'll probably, I think this goes into tomorrow. I'll tell you how to like open up your machines so that you can draw on each other's whiteboards, which is always good for a laugh. Yeah. Yeah, and it can send you the whole tweet, in fact, and then you can add it on the client side to a list of tweets. Yeah. Yeah. I mean, the server does tell you that there's a new tweet, but you don't have to, like, otherwise you would have to be requesting it constantly. It's like, are there any new tweets? Or, like, refreshing the list of tweets and then checking, like, doing a diff versus the tweets you have and updating the list. It would be rather inefficient otherwise. Yeah, exactly. Yeah. Yeah, WebSockets are a great way to implement PubSub, which is it's a the publisher subscriber protocol. We have a bunch of subscribers that can say like I'm interested in this, and then publishers that publish notifications about that, and the subscribers receive those event streams. All right, cool. I will make pairs and open this up.